Atusa was founded in the north of Spain and has established its presence throughout Europe. Atusa employs more than 1,100 people in 8 different countries. The headquarters of Atusa are located in Salvatierra. The rest of the members of the group are Helmer in Mondragon, Berg Montana Fittings in Bulgaria, 5 subsidiaries in Portugal, France, Germany, Italy and Turkey, and a sales office in Poland. The hard work of everyone involved with Atusa and the daily commitment to being a qualified supplier to the most demanding markets has determined our position as one of the leaders in the market. Atusa has 7 logistic warehouses, one in the head office itself, another in the facilities in Bulgaria, and another 5 in our subsidiaries. The distribution of a wide range of products is carried out from these 7 points. The sectors covered include those such as sanitation, heating, fire protection systems, industrial installations, electrical irrigation, building and others. Atusa has 3 production plants with a capacity of 30,000 metric tons, fitted out with modern installations, among which are electric melting furnaces, automatic molding lines, heat treatment ovens, hot dip galvanizing lines, threading machines, CNC and automatic packaging. Our experience in the production of different materials, qualities and finishes, and the knowledge of our R&D department ensures an effective development of the production in every phase and allows us to advise our customers as regards customized solutions. The process starts with the gathering and storage of raw materials, scrap and ferroalloys, whose quality greatly influences the success of the end product. The correct weighing and dosage of the components is essential and is carried out automatically. Mixed materials are transported and put in the electric induction furnaces, leading to their fusion according to the established parameters of the process. The temperature change is monitored periodically, along with the extraction of slag, and a sample of liquid material is taken for analysis. The study of the chemical composition and the cooling curve keep us informed as regards the correct evolution of the fusion process. The control of these parameters guarantees the right quality of the molten iron. Liquid metal is tapped into the transport vessel and transferred to the electric furnaces for temperature keeping and casting, situated at the head of the different casting lines. The whole process is automatic and controlled by an accurate program. Particles and gases are captured, collected and sent to authorized waste managers to be recycled. Refrigeration water is also conveniently treated. The molding process requires the construction and maintenance of patterns that are manufactured through sophisticated numeric control programs and finished manually by experienced workers. The final result is high precision tooling. Cores are produced with silica sand, whose grains are conglomerated with special resins and can be solid or hollow. Here you can see the print left by the tooling, giving shape to the inferior mold. On this print, the workers place the cores meticulously so that the piece produced is hollow. Following this, drag is sealed by cope before the injection of the molten iron at temperatures of over 1400 degrees centigrade on the previously shaped mold. Afterwards, it is passed through a cooling circuit before the removal from the casting of the heads, runners, gates and risers, which are the channels through which the molten metal travelled to reach the component itself. Finally, the castings are cleaned by shot blasting. Moulding can also be carried out in a vertical position. Here we can see a pattern for the moulding of elbows and the positioning of the corresponding cores. In both types of moulding, temperature, injected molten iron, cooling time and the characteristics of the sand are determining factors and therefore are strictly controlled by computer systems. During the unmoulding, castings are submitted to different inspections and specific tasks in order to guarantee the correct metallographic structure. The result of these controls determines whether the batch will follow the established process or will be refused. After cleaning by shot blasting and before passing to the following processes, the pieces are sorted out by references. Heat treatment has the purpose of achieving the malleability of the pieces by partially eliminating the carbon in a controlled atmosphere. Castings are manually placed in special baskets according to an established order. Afterwards, they are transported to the entrance of the ovens where they are introduced cyclically. Every load stays in the oven between 68 and 76 hours in temperatures exceeding 1040 degrees centigrade. The atmosphere being continuously controlled with sophisticated electronic devices. The pieces, which are now decarburized, are submitted to malleability tests. We can see how the same piece breaks before the heat treatment, and on the other hand, after the treatment, it is deformed under compressive stress. This because it's now malleable. Galvanization is carried out to apply a protective zinc coating to iron in order to prevent rusting by creating an alloy iron zinc that covers the piece both inside and outside. In order to do this, cleaning operations such as shot blasting, acid bath and flux are required. Castings are placed in special racks. After drying them in an oven at 110 degrees centigrade, the pieces are dipped into pure molten zinc at temperatures above 440 degrees centigrade for a previously programmed time. Following that, the pieces are cooled in a quench tank to reduce their temperature and prevent unwanted reactions of the newly formed coating with the atmosphere. At the end of the process, the thickness of the zinc layer is controlled. Generally, the machining of the castings consists of the threading, cutting or facing made by turning machines designed for this purpose. Here we can see flash removal operations carried out on different pieces using articulated robotic arms. For the chamfering and tapering of the internal and external threads, modern CNC transfer machines are used, offering excellent precision and versatility, working in a sequential and automatic way. The diameter of the threads, their profile, alignment, conicity and other technical parameters are checked systematically with normalized and certified gauges. After machining, every single fitting is tested by differential pressure automatized checking to verify their correct tightness. In some cases, this operation can be carried out manually. Finally, the castings are subjected to random inspection and, if called for, unitary specific controls are carried out. The pieces are counted automatically and packed, accordingly identified in cardboard boxes. This information is clearly reflected on the labels. In order to be accepted, all products received from outside the company are properly controlled. The product, once identified, is entered into the warehouse and placed in the position set by the system. The warehouse is 12,000 square meters in size and is equipped with a complex program that allows the management and traceability of the goods in real time. For the preparation of the orders, a radio frequency system transfers the information to each work area to arrange their dispatching. Atusa holds the recognition of accredited European and international organizations, both its products and quality management system being duly certified according to the applicable technical standards. We understand quality and optimal service as an argument for our commitment, security and future. Supported by a wide distribution network consisting of our warehouses and our allied distributors, Atusa is present in the most demanding markets, distributing a wide range of products consigned to comprehensive sectors. Our great versatility to supply diverse materials, qualities and finishes, together with our powerful distribution network, allows us to be a supplier in very different sectors in more than 40 countries.